Good. Evening to everyone. Glory to Ukraine. Super. Not tired yet. Everything is fine. This is the last, but quite important topic: architectural anti-patterns. About myself. Oleksandr Savchenko, Ukrainian, father of 2 children. This is probably the most important. Everything else is secondary. Our agenda: first, we'll figure out what patterns and anti-patterns are. Then we'll go over the 4 main ones. It will be very interesting. From different perspectives. Patterns and anti-patterns. So, what is an anti-pattern? Martin Fowler has an interesting illustration that very clearly shows what it is. First, you choose a solution. Walk through this field of cornflowers, and so on, and so on. Then, this same solution seems like a dragon to you, and you need to do something about it. Neil Ford essentially has the same idea. An anti-pattern is a more methodological term that he introduces in his evolutionary architecture. I think each of you has seen this book. An anti-pattern is a practice that initially seems like a good idea, but then you realize it's actually a mistake. It would have been better if he hadn't done it at all, and the alternatives would have been better. Something like that. The second thing that exists in our architecture, besides the anti-pattern, is a pitfall or a hidden trap. It's like the same thing, but it was something wrong from the very beginning. Really, something is not right. And why did we choose it? Incorrect. There was some kind of analysis or something. It's unknown. Let's figure out where and what it is. We all know where to find patterns. There are tons of books there. Say Neil Ford and Richard as a separate architectural school. Microsoft has brought us a rather interesting C resource, Azure. They have already named it the Azure Architecture Center. Previously, it was the Microsoft Architecture Center. The books on the bottom row, I think, are well known to everyone. Next is Microservice I/O, an architecture that was once publicly accessible to everyone with a magnificent catalog of patterns. Now they've put something behind a paywall. You have to pay money. Well, it doesn't matter, but you can just remove the placeholder in the web browser, and everything will work. Well, that's that. Yes, by the way, everything works. Now, what about anti-patterns? Well, I started digging where can these catalogs be found. And I traced it back to 1998. And then I realized, well, they even wrote a book back in 1998 called Anti-Patterns. 1998. How long ago was that? 26 years ago? Well, that's really a long period of time. You can find 41 anti-patterns there, and they called them mini anti-patterns. And I even added a suffix there, like MK. This is called a mini anti-pattern from 3 categories: architecture, development, and project management. Currently, if you look at this catalog, it's really relevant. Well, 100% relevant. More or less the latest ones. Someone has already made a site, and we keep adding more content there. This is an interesting source making. Basically, they took everything from this book and just adapted it to our 2020s, whatever the years. The second one they called Architecture Anti-Patterns. There are 11 anti-patterns. Also, quite decent. You can see what happens next. Various schools also talk about anti-patterns. For Neil Ford, it's not just anti-patterns, but also pitfalls. This is exactly building evolutionary architecture. A magnificent book. I recommend it to everyone. And Mark Richards separately wrote another book about microservices. Everyone was dabbling in microservices in the 2010s. Now, suddenly, everyone has returned. They're coming back, doing something with them again. Well, anti-patterns exist there too. Also, DevOps. DevOps is a separate category. It's an entire culture. And there are 2 excellent books, Operational Anti-Patterns, where you can also grab all that information, and of course, the DevOps Handbook. At the same time, DevOps as a culture is also about team topology, how different teams work with each other. It's not just about which technologies we bring in, automate something, security, reliability, or having a service running at night, and so on. It's also about how different teams interact. Therefore, there are also anti-patterns or anti-types of how to and how not to work in DevOps. This is the average one, as you can see, a fantastic resource. And it also brings us AWS guidelines in DevOps. They have a well-architected framework. By the way, I wonder, do we have any DevOps people in the audience? Yes. Oh, great. Everyone probably knows the well-architected frameworks. Everyone has looked at them at some point or another. In AWS, they have described 116 anti-patterns from various categories. It's fantastic. You can also take a look from there. There are organizational and development lifecycle ones. How to do it, how not to do it, and observability. What should be done, what shouldn't be done, there's security. Well, that's about it. When I started thinking about which specific anti-patterns would be interesting, I remembered how they can be categorized. Let's take our enterprise architecture. For those who don't remember, it's BDAT, Business Data Architecture Application, and Technology. And we can take and categorize, let's categorize our anti-patterns within enterprise architecture like this. And today we will look at 4 of them. The first of them is designed by committee. In the anti-pattern itself or pitfall, which is also a hidden danger, lies how we will fix the problem. What problem might arise in this case? First, no one presents the architecture, or it somehow exists. Someone is doing it. Developers are collectively creating it. Then we end up with an overcomplicated design. Everyone recalls the big ball of mud. We have a bunch of technologies and so on and so forth. It's all very difficult to maintain. DevOps are simply in shock. What have they done here? And so on and so forth. Secondly, we have some kind of super architecture, but everyone contributes to it. It can be brought by one technical lead, another technical lead, and the QA lead also says, oh, I know something about architecture there. That's how it happens somehow. That is, many people want to contribute to the architecture. It's super great, but at the same time, we have long meetings. Who knows? I definitely know that everyone has had that 4-hour or all-day meeting. Raise your hand. Let's talk about some architecture. Raise your hand. Oh, great! That's because everyone wants to contribute there. Meanwhile, what do we have? Word delivery, some release cycle, we are missing. Some deadlines for the release, something like that. And then there's time to market. Product managers say, no, it's sad. Everything is just sad for us. The last situation is also not very good, but for some reason, it's forgotten. Okay. We created the architecture, but we forgot to understand how we will measure our product once we release it somewhere. At the same time, we remember whether we implemented something well or poorly only during the release, just before the release. And this preparation for release can really take a month or even longer. And after the release, we have this lack of observability in English, or there's no clear picture at all of whether we released a good product. And the business might come and say, the KPIs weren't achieved. Let's redo something. A new release, etc. Classic situations. What do? Everyone starts contributing. Okay, this is a classic situation. Our collective mind prevails. So let's hire or appoint someone as an architect, a dedicated architect. The person is just as shocked. What could happen in this case? And here we start thinking about anti-patterns. The first one, and it's a classic in the literature, the architect plays golf. The architect came, created the architecture, and that's it. Goodbye. Then the developers work, and logically, the architect also works because they have their own backlog. They come to him or her. What's going on there is unknown. So somehow they work. Developers work. They might work in Scrum with a delivery lifecycle of 2 weeks. The architect works using Kanban I work with Kanban, that's it. Come to me, add tasks there. The second story, the second anti-pattern is the tower. Tower architecture. When the architect is unavailable, they say, I am the architect. I do architecture the way. I know how. I see. The classic genre is unfolding here. I am the architect, I know what to do. I don't talk to anyone. Well, okay, I talk to the business because I am the architect. And there are also regular meetings with the CTO, something like that. What are we doing? And here is where the first fear of this architect arises. I am not covering all the requirements. I am making this camel, like a horse, 2.0. It essentially achieves some requirements, but at the same time, it's unclear whether it definitely achieves the other requirements. And here, we come to the technical or design committee. Sometimes it's also referred to as the architecture review board, depending on the architectural framework. Who can we include there? Architects, technical leads, or a technical lead, depending on the scale, and the QA lead. Let's not forget about quality. It's the most important thing, as it determines how we will measure our product. DevOps, definitely. DevOps, yes. DevOps should be there. Delivery lead and the product lead sets the business priorities, business features, etc. How do we proceed? What are we doing? First, we choose architectural frameworks and methods. That is, I will now show this flow, how you can set up this design committee. We choose design methodologies like essays, top-down architecture. Again, the Microsoft Architecture Guide is an entire process. 3 DOFs are needed at most. For those who don't know what 3 DOFs are, we simply take alternatives, compare them, and remember that we compare not just by attributes we invented or that ChatGPT provided, but by context, by the context we need. By the way, for those who try to do 3 DOFs in ChatGPT, it's a bit sad, as ChatGPT is still doing 3 DOFs there. We chose the methodology. Great. What happens next? Now we need to come up with a process for how people can also contribute and what will happen. First, we have the requirements. Then for those who don't know the term ASR, Architectural Significant Requirements, we identify these requirements, which are functional requirements. And product managers. Then constraints, concerns of different stakeholders, so we talk to different stakeholders. And of course, quality attributes or attributes of quality, sometimes also called non-functional requirements. Next, we specify the principles on which our architecture will be built, such as cloud first, not cloud first, SaaS first, and so on. Then we create these 3 drafts, about which I already mentioned, alternative solutions. Then we write ADRs. Dimitro, I think, explained in detail what that is. It's simply a format, how we document all our decisions. We chose MongoDB. We did a trade-off analysis before that. Great, we documented it. What are the alternatives? Why did we choose MongoDB? For example, if we have several alternatives. 6th point, FCS, prototype, developers. Come here, we will do this thing with you. 3rd point, we already know which framework will work. Flow. There are even FCXs there. Super. Now we choose our tool set. Sometimes it happens that the architecture is there. Someone draws in draw.io, someone in Lucidchart, Plant UML, C4 model. We need to agree on at least a minimal set of what will be done and what the minimal set of diagrams that need to be provided will be. 4th, of course, is the implementation of ADRs. Again, AWS made an effort and even drew a UML diagram. How to implement ADR in your process? Here is the link. The presentation will be available later. You can take a look. AWS really made an effort here. Well done. So what do we need to do next? Now this architectural group or design committee drives the architecture. Great. They have ASRs. That's the thing on top, the yellowish one. They chose the architectural method and architectural principles. They sync up regularly there. Once a week, this group, the QA lead and DevOps, sync up and create software architecture documentation or SAD or a document. It doesn't matter. If it's Confluence or Notion, they store it somehow. The main thing is a unified format. And who do we need to bring here? The delivery team. We need to explain to the delivery team that they should also contribute something to the architecture. How? These are RFCs, request for comment. That is, people know that we already use ADRs as a format. Great. Therefore, they are familiar with this framework. We teach them. I mean, the design committee teaches all these developers, and they can create ADRs in the form of proposals. That is, the status is proposal. And then the same design committee sees once a week that Sergey or someone else has created a new ADR in the status of proposal in the form of a request for comment. We accepted it. Super. And of course, the delivery team knows that they will eventually have a POC or a prototype or something else. And of course, product delivery. In principle, everything is good here. Now, we need to understand when we have problems. In anti-patterns, unfortunately, when I was searching through various resources, everyone talks about the problem, okay, sometimes the solution or refactoring, as it's also called, but metrics that can show that we really have this anti-pattern or pitfall, there are none. But it's worth knowing about them. So if you see that you have very long meetings, or you notice that your architecture and implementation are two completely different worlds, or for some reason you have a lot of refactoring, then action, I think, will help the most. Delivery managers come to us and say, no, you're doing too much refactoring there. And of course, thirdly, as you can see, complexity and debt. Some code, complexity metrics, or technical debt that you notice, or an interesting acronym, CLOC. This is the number of defects per 1,000 lines of code, which might, I don't know, help us in SonarQube or something else. They can also help indicate that something is wrong here, that we're not diving into the architecture correctly. Therefore, it's generally worth understanding and collecting these metrics in some way. Here again, DevOps can help implement something, and also the delivery manager, because time is usually very indicative in this case. In total, 9 steps. In principle, we already know and have discussed what needs to be done to fix this problem when we have a collective architecture. We appoint an architectural leader. Anyway, they should facilitate. One person should facilitate these regular syncs once a week or twice a week. I would recommend once a week. Then we establish this technical design committee and so on. In principle, the most important are these 9 steps, and the last one is to gather feedback from the developers. Guys and girls, are we driving the architecture properly or not? That is, so that this design committee group also evolves. The second anti-pattern or pitfall is the data virus. Has anyone heard of such an anti-pattern? No. So we will figure it out together. A bit of statistics. There is a company called IDC, and what do they say? They collected statistics regarding data worldwide, and they came to the conclusion, and this, well, several sources have been verified. Well, IDC, they have a very large report stating that in 2025, which is not far off, there will be a total of 175 zettabytes of data in the world. That's just, well, overly a lot. Meanwhile, 402.45 million terabytes are generated every day. So right now, there's just an overly large amount of data in the world. Meanwhile, 90% of it are replicas of existing data, and only 10% are unique data. Another statistic, provided to us by Veritas. That's also a company that deals with data reports and so on. What do they say? So there are these How many were there? Time, 175 zettabytes of data, and 52% of it is dark data. What is dark data? It's data that has been collected but is not used at all. People have already left the company who don't know about this database and didn't know half of the tables themselves. And yet it exists, and this is a big problem. What is the big problem? First of all, data centers. Yes, you could say Google, we don't delete anything at all. Super. We archive everything there, move it somewhere, but for some reason the concept of FinOps appears in the 2010s, even in the second half of the 2010s. A person who, for some reason, will optimize costs, suddenly, we don't delete anything. Secondly, now, in the 2020s, the concept of EcoOps has appeared. Suddenly, yes. EcoOps is a person who, along with FinOps, is involved in data optimization, but also optimizes electricity, carbon usage worldwide, etc. These are such ecological operations people. What is the problem with the bad data virus? We have some golden source. Great, there's a bad data virus there. We create a replica. Availability, everything is fine. What happens next? Next, we create some downstream tool so that data from the golden source, for example, we implement SAS. And now our bad data, which is not used, is actually being worked on by people in a third company. No one knows what this data is, but it is needed. They then appear in SAS, then appear in the data lake, and in, let's say, the year 2023. Last year, we start implementing what for them? Generative AI. And we break down high-level abilities, and then we train our model, the vector database, and then the LLM. And there we also find what? Our bad data. And why is that? Because we have this fear that we are deleting some data. And that's why this anti-pattern, unfortunately, exists. What needs to be done? Firstly, metrics. Once again, DevOps will help us as much as possible here, implementing some observability tools that will help us understand if we have this bad data, whether we are using some data, like access logs and so on, how much the data changes at all, maybe nothing changes at all, and so on. What needs to be done? How should this be fixed? This is a clear data governance strategy. First, you need to audit the data you have. Then implement a clear data classification scheme. Then create a data retention policy and automate the deletion of this data as much as possible. Someone, once I know at a conference, this year also said, let's train AI to look at this bad data and then delete it itself. A brilliant plan. I think this is exactly what we need. But I think each of you has a more philosophical anti-pattern or pitfall. I think each of you has product projects. It exists. And here it's worth understanding. Is it really bad data? Perhaps it should be used there, so I would call it not an anti-pattern, but a pitfall that can create problems. Next, now we move into the world of application software development. And we all probably know the anti-pattern of the Swiss Army knife. Please tell me who knows what the Swiss Army knife anti-pattern is? Oh, there are many, many people here. It's a classic of the genre. In our class called Manager, all the business logic exists. Well, not all of it. There's another manager that contains the other 50% of the business logic. And now, the world is changing, of course. And where are we going? We are moving towards a distributed system. And at this conference, you've already heard about the migration from monolithic architecture to some kind of distributed or service architecture. What is happening? We have a monolith, a database. Then we create a couple of microservices, share the database, they use it, and we make some microservices. Well, they are just smaller. A macro service now, that uses its own database. Let's move on. The next step, what is the next step? We implement a messaging system. Great. And we have a dilemma. Orchestration, choreography. I think everyone already knows what that is. Thank God. But these direct connections remain. Between services, what happens next? And then someone comes along and says, oh, let's start adding functionality to the messaging system, like service binding. Let's also add security, failover, protocol switching. Then suddenly add proper transport, load balancing, and so on. And, well, okay, we success, and we start removing these direct connections. Everything is great, everything works, and seems to be good, but something is not right. Something is really bothering us, and someone from the 2000s, from the 2010s, hints. I've seen something like this before. We had a monolithic application, we had a database, triggers, procedures, functions, and there was also, by the way, a core team that supported all of this, separate people. Just like in this case, by the way, I also skipped the fifth step, where separate people support the messenger system, yes? Write separate plugins for it, add them, and want to contribute to this enterprise service bus, something like that. It's the same thing here. And thank God, during interviews, you don't, well, very rarely ask what triggers, procedures, functions are, but at the same time, you remember how it was when you were in this core team. What challenges? When we have a distributed system, John, and some Kafka, or well, an enterprise service bus, or a BPMN system is introduced, a business process modeling system that orchestrates everything, there's choreography, and much more. First of all, our messaging system is overloaded. Secondly, we have performance issues. Well, the performance is dropping. Our DevOps are trying hard. DevOps are like mega supporters for us today. It's very difficult to make any changes. This core team is really overwhelmed. Well, the developers are piling on the scope for them. They are working an extra sprint because they need to do non-breaking change development and so on. There are a lot of problems. And meanwhile, when you set up a new person, well, a newcomer arrives. And the hidden business logic is on this USB stick. And you're like, we don't have documentation, you need to figure it out, you say. And this is the situation. When, in the 2010s, they started transitioning from monoliths to a service, I would say, to a service architecture. At the same time, everyone called them microservices. They started in 2020. Well, in 2017. 2020, I specifically looked at those articles on Medium and so on. During this period, at the end of the 2010s, topics began to appear like stop using Kafka as an enterprise service bus. For some reason, that's how it is. And even Southwork, the company that releases the technology radar, they released it in 2017 and 2018 as a kind of trending anti-pattern, which you shouldn't do like that. The ESB, anti-pattern with Kafka. This is actually quite an interesting thing, that it turns out someone already thought about us back then, 5 to 8 years ago, that probably it shouldn't be done this way. How it should be done is another story. But today, we are talking about what shouldn't be done, what is not worth doing. And why does this happen? Why do we bring in this enterprise or Kafka and so on? This fear, because we will have a big ball of mud and we will have a big mess. And then Kafka will solve everything for us, or some messaging system, or something else, or streaming. And we will do choreography there, we will implement Saga or something else, but we won't have a big ball of mud, yet we will have some hidden business logic or something else. There is such a fear. I'm not saying that it's not worth taking enterprise buses or something else. Sometimes it's just a pitfall that needs to be considered. You need to save yourself, because, well, something might go wrong. This dragon will appear, and there will be some kind of trouble. What real indicators in observability can help us here? Firstly, we need to understand the utilization of our messaging system, streaming system, USB or BPMN system. We need to understand the total number of message types we have and the transformations. What is our service coupling? How many services depend on a specific type of messenger? Why do we have so many of them? How does this failover cluster work in general? Or maybe it doesn't work at all? And these indicators can just show that we probably have some problem. Okay, well, a real problem. What do we need to do? It's simple here. Again, a list of 8 recommendations. You'll look at it later. We review our messaging system, try to refactor it. We create simplified message types, minimize this type transformation, and try to decentralize our business logic. Well, now we're talking about microservices. Great. Well, it seems like everything is more or less in place. We bring in some additional details, and so on. The last one is quite interesting. This, I think, is where DevOps comes in, which is why I also mentioned DevOps, operational over-tooling, when we have too many tools. Why do DevOps help us? Because it's development and operations. We have teams that need to support both development, automation, and quality gateways. And then there's orchestration. I mean our containers, containerization, virtualization, logging, and there's also the SRE culture. That's roughly how it happens. Here, the DevOps help us, but what do we have at the same time? We have the fear again that we are doing something manually, and let's implement a new operational culture. Pros, we maximize development time. No one does anything manually, everything is great. Challenges, at the same time, the workload of the same DevOps increases suddenly, and then our security somehow fails, again, suddenly. Although automation helps with this, again, my point is that this can be a pitfall. It's not necessarily a real problem, but it can be a pitfall that needs consideration. And again, an anti-pattern emerges, which I have renamed from an anti-pattern to a pitfall called the no-ops mirage. That is, we say we are bringing this no-ops right when we have nothing manual at all. Meanwhile, our DevOps spend about 6 months working to ensure everything is no-ops. Then, when it is already released and incidents occur, for some reason they start doing things manually. And again, this manual work happens, and the maintainability cost increases because when we add new features and something in this no-ops, well, we also need to add the same thing to no-ops. What are we doing in this case? Our engineers want to add some new technologies because in no-ops, well, again, it's not a manual process, and some technologies should help us. Who has seen this periodic table of tools? Raise your hand. Oh, not many, but it's very interesting that some have seen it. DevOps? DevOps, right? Oh, DevOps, people know it very well. What's the essence of it? It's digital AI. There's a website where you can simply gather information about various tools in different categories. The second website that provides even more information is Cloud Native Landscape. I see hands. We're already there. Yes. Again, you can find information there about the tools worth using, some descriptions, alternatives. But when you introduce a tool, what should you do? Trade-off analysis about what I initially talked about. You compare tools with each other depending on what your teams need, not just what you need. And you discuss beforehand what needs to be done. But the problem of over-engineering can really arise because you say, yes, one team, another team. We have Agile here. You can use anything you want. And when you come, for example, if you work in outsourcing and they order an audit or architecture evaluation, you come and ask, do you have a unified process like CI/CD or some tooling? Oh no, we used to have Jenkins, but now we're trying GitHub Actions. And actually, we also have our own GitLab. And you think, okay. Because we have Agile, our teams are self-sufficient, they can contribute something somewhere. Yes, it's normal for teams to be self-sufficient and able to contribute, but there should be some limitations on what is worth doing and what might not be. If we are changing one tool for another, boom, well, okay, let's discuss this thing. And here, when we have overtooling, the following issue arises. We focus on tools rather than on people and what they actually need. And DevOps, what is not just about automating processes. It's a whole culture that needs to be understood. And the third point, and now let's recall what I talked about, the bad data virus. This automation brings what is called data explosion, a burst of data in your system. You end up with more logs that need to be managed. Then you have logs from pipelines, builds, artifacts appearing. There, for example, if you work in IT, and also, separately, there are still old emails and other things. And indeed, automation further increases this data, which we know is the bad data virus. What should we pay attention to in order to understand whether we have many tools or not many tools? First of all, utilization. How much we use the features of a particular tool, how much we use it at all. Meaning, the frequency of using a specific tool. Next, how much time we have spent on integration and the same upgrading. How often it experiences downtime, failures, and so on. And of course, there's the cost. How much do the licenses cost? Resource utilization. And there's a large set of factors that help us understand whether it's really worth having all these tools we have. Maybe let's limit them at least a little. So, what needs to be done? First, conduct an audit, document what we use and what we don't use. Then, perhaps I found in the literature a concept called governance or DevOps tooling committee. That is, it's some kind of committee. Perhaps it's the same design committee that will standardize the tools in our platform, program, system, project, and so on. What do we need next? It's a tool adoption strategy, standardization, and of course, automation of deploying these tools used for observability, not just the automation of our containers in Docker, which the developers have done. And uttam, so on. And of course, it's very important to share knowledge with our development teams so that everyone understands which tools we are using, where, when we will have a roadmap for tool replacement, and where it might not be worth using certain tools yet, instead of engaging in resume-driven development, another anti-pattern that, of course, you all know, but before even thinking about your system and understanding whether we are using an anti-pattern or not, and whether it is definitely an anti-pattern. Because, as I said, it might not be something bad from the start. So, we should understand. Maybe it's a pitfall, this hidden danger, and we will just live with it. And thank God for that. But maybe there are some alternatives that are worth implementing later. And from that, where to look for these paths. First of all, you need to know some catalogs of anti-patterns, those problems, metrics, and fitness functions. And the fitness function is how to measure these metrics, and of course, an action plan, something like that. There are reference links. So, the presentation will also be available. I really want to thank the Armed Forces of Ukraine for allowing us to gather here. We didn't even have any alarms. I sat all day watching, and there weren't any. Yes, that's why. I know that Fwdays is also collecting for similar devices. Our volunteer movement, Do It, is also collecting. We are currently collecting for the 129th Brigade. The Pokrovsk direction is very hot right now. So anyone who wants to donate, please, there's a QR code. So join in.
We need more donations, divine donations.
Yes, 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 yes.
Showing an example.
And the last QR code, there is a link to my presentation in a PDF file. I think everyone will need it right after. Oh, that's more everyone immediately took out their phones. Yes, here you can. This is a link to a public Google Drive. There will be a PDF file where you can view all the slides you have already seen. Thank you very much.